Okay, so topic we have applications of mean and variance of combined random variables. As in exercise 13E, we discuss how to find out the mean and variance of combined random variables. There we learn this skill, right? And here we have problems. What problems? So we will learn how to apply this skill to sort out the problems. Okay, look at this question number 1, exercise 13F, and question number 1. So if we read this question, cookery book is translated from Russian into English. Each page has 2 separate sections, ingredients and method, which are translated by different translators, working independently, assuming the number of translation errors in the ingredients section and method section, follow Poisson distribution with parameters 0.7 and 0.6 respectively. Find the probability that on a given page there is at least one error. So this is a case of translation of book, and we have 2 pages, 2 separate sections. One is the ingredients, and the other one is the method. Right. Now this thing is given. It is following Poisson distribution. It's given in this one in the question, and okay, so we have to find out the error probability of at least one error, and the probability and the parameter of error in ingredients is 0.7, and in case of the methods 0.6. Okay, the Poisson distribution. So remember, we have 2 different portion. One is the ingredients, other one is the method, right? And we have to find out the probability of one error. So error may be in ingredients or maybe in method, anywhere it may be. So it means we are looking for the combined. We are looking for combined random variable. Error may be anywhere, either in ingredients or method, right? So we will have the new parameter. We'll have new parameter, and we are adding this 2 parameters, 0.7 plus 0.6. Okay, so new distribution will be Poisson distribution, and its new parameter will be 1.3. Why 1.3? 0.7 plus 0.6 is 1.3, right? And now what we have to do, we have to find the probability there is at least one error. So at least one error means, right, either x is equals to 1 or more than 1. This is at least one error. Okay, so you have to find out the probability for distribution x is greater than or equal to 1, right? So since you are using this Casio, so it does not have the other options. So here you will do 1 minus probability of x equals to 0, either less than equals to 0, but 0 is the first number. So you can write either x less than equals to 0 or x equals to 0. Okay, and you can use your calculator. You can check the probability of x equals to 0, and then 1 minus that will be the probability of this portion. Am I clear? I think the maximum load a lift can carry is 375 kg. The weights of adult males and females are distributed normally with the means 85 kg and 60 kg, and standard deviation 10 kg and 7 kg respectively. Find the probability that a load of 3 women and 2 men would be too heavy for the lift to function, assuming that the weights of 5 adults are independent of each other. Okay. So now what problem? There is a problem that lift cannot carry more than 75 kg. The capacity of lift is 375. Okay, so we have some adult male and females, and their mean weight and standard deviation we have here, right, in this question given. Now, so we have here three women. Yeah, three women and two men. So we have to find out what it means. Three women and two women. Their weight will be too heavy for lift, right? So see, we have here two different random variable. One is the man, the other one is the woman. Understanding? In men we have to take two men, right? In female we have to take three females. So it means first of all we need to find out the new for distribution, new mean and new variance we need to find out. Okay. So first of all I will suppose this is here. We have a male and their mean weight is 85 kg. Yes, mean means mu. Okay, and their standard deviation means sigma is given 10 kg. Yes, male, suppose this is m variable, and so this is the mean weight of female, that is 60 kg, and their standard deviation is 7 kg. We have to find the probability for this 2 male and 3 female. So suppose x is the combined random variable. So it will be normal distribution as per condition given in the question. So 2 mil. So new mean will be 2 times of 85 plus 3 times of 60. Okay, 3 times of 60. Why? Because 2 mil. So 1 male weighs 85. So 2 means 2 times 85. One female weighs 60 kgs. This means 3 female 3 times 60. And standard deviation, in case of standard deviation, we know here standard deviation, but we in the normal distribution, we write the variance. So square, we have this is 2 times, right? 2 times square of 10 plus 3 times of square of 7. Why 2? Because 2 male, right? And why 3? Because there are 3 females. So we will simplify it, right? So after we simplify it, and you can take the help of calculator to simplify it. I simplify this one, so I get the new mean is the 350 and new variance is 347. And now I'm writing this in this standard form, because if you guys know the standard form to write a normal distribution is x, right? Normal distribution, mean and sigma its square, because we need mu and sigma values to input in calculator. So sigma square equals to 347. So sigma will be equals to square root 347. Okay. So 347 I'm writing as a square root 347. It's a square. So we know mu is this. Mu means 350 and sigma will be square root 347. This we will input in our GDC. So, okay, so this is the new distribution, and now we have to find the probability, right? So probability for distribution, x is a random variable and its probability. If you see that statement of the question, the maximum load a lift can carry is 375. It means if their load goes more than 375, lift will not be able to function. Okay, so you have to find out the probability for a discrete random variable greater than 375. Okay, and you have mu, you have sigma, so you can use your GDC and you can see what will be the probability of this part. An emergency food parcel consists of 3 bottles of water, 2 bananas, and 2 bars of chocolate. The weights of all the items comprising the parcel are distributed normally. So it's clear. It's a normal distribution. It's a distributed normally. We have water, banana, chocolate, mean, and standard deviation. What is the probability that the entire food parcel weighs more than 1 pound? Okay. So you have to find out the probability. 1.5 kg means 1.5 kg means 1500 gram, because other units are given in grams, so that's why. So it means you have to find the probability where x is greater than 1005 gram. Okay, so for a parcel, you just design for a parcel, design the this thing, probability distribution, right? So there is a normal distribution. X is a normally distributed. We have 3 water bottle. Okay, am I clear? 3 water bottle. So 3 water means 3 mean will be 3 times 300. Then there are 2 bananas. So 2 times 1 banana is 180. Okay. Then there are two bars of chocolate. So 2 times 1 chocolate is 1 chocolate is 100, including the weight of box. Box is 16. So this is what this one the mean for the standard variance. 3 times of 2 its square plus 2 times of banana is standard deviation 7 square plus 2 times chocolate to its square and box 0.5. This will be the distribution. If we simplify, we will get this is 1476 using calculator, and this is 118.25. Okay, this will be the distribution, new normal distribution, and you have to find the probability for 1500 gram. So using calculator you can find out, it's easy. Okay, right? So up, I think now you